Hi, in this video I'm going to show you how to solve differential equations using Laplace transform in Mathematica. In the last couple videos I showed you how to take the Laplace transform of a function f of t in Mathematica and also how to find the inverse Laplace transform of a function big F of s in Mathematica. So we know how to do those two things. Now we're going to put those two things together and solve differential equations using Laplace transforms in Mathematica. Okay, now this is not how I want you to do your homework problems. I still expect you to do your homework problems using paper and pencil, but this is a great way to check your problems step by step. I would strongly encourage you to do that. It also gives you good skills with Mathematica, so it'll also develop your skills with Mathematica. So please make sure you guys go back and check your homework problems from section 7.5 with the method that I'm just going to show you in a second. Okay, all right. Now before we do any of this, okay, we'll have to define this differential equation, initial value problem, and store it into a variable. If you recall, to store something into a variable in Mathematica, we create a variable a and we go equal to 8. So that'll store the value of 8 in the variable a. So we're going to do something similar. I'm just going to call it P1 for problem 1 equal to. I'm going to store this initial value, this differential equation for now. I'll worry about the initial conditions later, but I'm just going to store that differential equation into that variable. So you go y. Okay, so to store the differential equation, remember y is a function of t, so we have to specify that. So primes t, okay, plus 4y prime t minus 5y of t. And now remember, this differential equation means that the left hand side is equal to the right hand side. So when we type this equality, we have to type in double equality. So we go double equality t space, remember to use a space for multiplication, and capital E for the Euler's number, caret t. So that'll store that differential equation into the variable P1. So if you type in shift enter, it'll spit it out. Okay, so it's stored that. So if you don't want to see this, you can just come out here and put a semicolon, which is what I would recommend. But first make sure you type it in to make sure you get the differential equation to pop out as output. But once you see that, come back and put a semicolon and press shift enter, so it's gone. It is still there in the variable P1. So now how would you do this on paper and pencil? If you were solving this with Laplace transforms, you would take Laplace transforms on both sides. So let's do that. So let's go Laplace transform. We'll use a built-in function in Mathematica called Laplace transform. We're going to take Laplace transform of P1, okay, comma, right? It's a function of t, comma, we want a function of s. So if you press shift enter, it'll give us that. Now when you do it with paper and pencil, instead of, we call what's the Laplace transform of little y of t? We call it big Y of s, right? So Mathematica doesn't know that, so it'll just call it Laplace transform. So this is really big Y of s. This is really big Y of s, and so on. So let's actually tell Mathematica to do that for us, okay? So what I'm also going to do is, this is going to be step 2, right? So I'm going to type in P1, 2. That'll basically mean step 2, and I'm going to store it in, store this Laplace transform into this variable called P1 for problem 1, step 2. You can call it whatever you want. And then what I'm going to come do at the end is I'm going to show you what to do. You put in a forward slash and a dot. In Mathematica, this is called a replacement operation. What we're going to do is, in this expression, we're going to replace this long thing, Laplace transform square bracket y of t comma ts, with big Y. So I'm going to copy this, Control C. I'm going to come out here, paste it, and then put a dash arrow and big Y. So what Mathematica is going to do is, wherever it sees this expression, it's going to replace it with Y. That's what this forward slash dot tells it to do. So if you press shift enter now, we're not going to get this ugly thing that we got the first time. We're actually going to get something in big Y, which is exactly what you would see when you do it by hand. Okay, then what would you do? You would replace all of these initial conditions with what we have. So let's do that. We'll make Mathematica do, and we'll use this replacement character again. We're going to replace y square bracket 0 with 1 and y prime square bracket 0 with 0. So we'll use the replacement character to do that. Okay, So now we're going to create a next step, P1, 3. That basically means step 3 equal to, alright, so we're going to go, right now this expression is stored in P12, so we're going to go into P12 / dot, okay. Now we want to replace two things. Out here we were only replacing one thing, so we didn't have to do anything fancy. We could just type this in. Since we have to do two things, we have to supply a list. So the first item in that list is going to be y square bracket 0, okay, dash greater than 1. So it's going to replace y square bracket 0 with 1, and y prime square bracket 0 greater than equal to with 0. So it's going to go into this expression P12, which contains this, and replace every occurrence of y square bracket 0 with 1 and y prime square bracket 0 with 0. Those are my initial conditions up here. So that's what this replacement character does. Since we have two things to replace, we supply it in a list. So if you press Shift Enter, you'll get that. Once again, this is exactly what the next step would have been if you were doing this by hand. The next step by hand would be to isolate big Y, correct? So let's do that. So let me show you how to do that. So you want to solve now, and you know how to solve in Mathematica using the solve command. So in this expression, which happens to be stored in P13, I want to solve for big Y. So I'm going to call it P14 step 4. I'm going to go solve, capital S. What are we going to solve? We're going to solve this expression for big Y. Again, I don't need to type in this whole expression. I can just type in P13. That's why I stored that into that variable, comma, big Y. And Shift Enter. Okay. Oops, I typed it in the wrong place. So let me fix that. Let's cut that. Come out here, paste it. And there we go. So we got that. But if you notice, anytime you use the solve command in Mathematica, it returns a list. Okay. So to get just this value, which is what I want, because eventually then what do we want to do? Find the inverse Laplace of this, correct? Which would be the last step. And how do we do that? By doing partial fraction decomposition to do that. But again, we don't need to do that because Mathematica has a built-in function called inverse Laplace, and it'll spit it right out. But first, let's get this expression. Now remember, there is a list. Curly braces means list. In the outer list, there's an outer list you can see, which I haven't highlighted. So if I type in double square bracket, that lets you navigate a list, 1, that'll just give me just this expression. It'll give me the first item from the outer list, which I haven't highlighted. So let me do that just to show you. There we go. Now I want to go into this list, which also happens to be another list since it's got curly braces. So if I type in comma 1, that'll go into that list and give me the first item, which is this. So you can see I get that. Okay. Now what do I want to do? Oops. Shift Enter. There we go. Deleted the wrong one. Alright, so I got that. Now, even though there's no curly braces, Mathematica treats this like a list. Do you guys follow? And treats this arrow like a comma. So there's how many items in this list? 1 and 2. The first item is Y. So if I type in another 1, I'll get Y. But if I type in 2, I'll get exactly what I want. So now P14 has this expression. Okay, so we've done this before with ODEs and when I showed you how to solve differential equations in Mathematica. So use that to navigate it and make sure you get the expression you want. So always start without typing this in. Don't just blindly do stuff in Mathematica. Start by typing this and see you get that expression. Now you can come and navigate through that list by using that to get that. Now that we have that, I'm going to create the next step, because if you were doing this by hand, you would do what? We would find, oops, let me delete this extra cell that I have. Okay, we don't need this either. Alright, so then we would do the inverse Laplace. So I'll create a new step and I'll type in inverse Laplace and square bracket. What are we going to take the inverse Laplace of this? Normally by hand we would do partial fraction decomposition and then we would do the inverse Laplace, but we don't need to do that. Mathematica will do that for us. But if you wanted to do the partial fraction decomposition, let me do that for you. So you can go apart. And what do I want to do the decomposition for this thing? And that is stored in what? P14 4. So that's easier to type in. That's why I stored in all these variables. Square bracket. So I'll do the decomposition first. There we go. And then we can take the inverse Laplace of this. So if you want, you could store this, but I don't. This step is just for your own benefit, but I'd rather go directly using inverse Laplace. So I'll go P1 4, comma, from a function of s to a function of t. That's what inverse Laplace does. Press that, and there's the answer to this problem. And this is done exactly step by step like you would do by hand. So you can come and type in your problem and store it in some variable and just go step by step here, and you can check your work. So it's really nice that Mathematica lets you do that. Now, in chapter 4, I showed you a built-in command that Mathematica has to do this. So let's use that. And that's desolve. If you recall, you use curly brace because you're typing in a differential equation. Y double prime of t plus 4y prime of t minus 5y of t double equality t space capital E raised to t comma y of 0 double equality 1 comma y prime of 0 double equality 0 curly brace comma y comma t. If you recall, this is how we solve differential equations in Mathematica, and this is what we did in chapter 4. You use the desolve command and we store that into something. So I'll call it f, you can call it whatever you want, and then if you press shift enter you get this, and this answer here is exactly the same as what I have up here. But let me show you that. How do we extract that? Because we got a list back, right? So if you recall, we put double square bracket 1 comma 1 comma 2, and then you can put a semicolon. That'll suppress the output so you won't see it. But then to see the function, you can just go f of t, because what desolve does is returns a function of t and stores it into this f. So now f becomes a function of t. So if you press shift enter, you'll get that. Now this doesn't look like this because Mathematica has factored some stuff out of this expression out here. Do you guys follow? So if you want to see that, what you can do is you can come out here, put 2 forward slashes and expand, and that'll expand that solution, distribute that 1 over 216, and there you go, get the same answer. So this is the built-in command in Mathematica, which you can also use to check your work. But if you do it using the way I showed you up here, then you can do it step by step and go through it just like you would do it by hand. So let me do one more problem really quick. So here's another problem, another initial value problem. So I'll call this P2. We're going to store it in variable P2. Y double prime of t plus 4y of t. Okay, double equality, because we are saying this left hand side is equal to the right hand side. For cosine, since it's a function in Mathematica, use a capital S and square bracket 2t. Alright, and you press shift enter. So now this variable P2 contains this differential equation. If you put a semicolon here, it'll suppress that for us. Then what do we do next? If you were doing this by hand, we would start by taking Laplace transforms on both sides. So let's do that. So we can go Laplace of what? We want to take Laplace transform of this differential equation, but we've stored it into P2, so we don't have to type this again. We can just type in P2, comma, it's a function of t, and we want a function of s. And that's what we get. And remember, Mathematica, instead of calling it big Y, it just calls it Laplace transform of little y of t. So to fix that, we can come out here and put a forward slash dot. That's a replacement. And I'm going to highlight this. I'm not highlight, select it, press Ctrl C to copy, come out here, Ctrl V to paste, dash greater than, that'll create that arrow, and replace it with big Y. So now Mathematica will take the Laplace transform of this and replace every occurrence of this with big Y. And I want to store this into a new variable, so I don't have to type this in later. Okay, so I'll call this P2 1. That will be step 1. We took Laplace transforms on both sides just like we did up here. Okay. Alright, shift enter again. So now this expression, this output 28 is stored in the variable P2 of 1. That's step 1. What is the next thing we would do? We would replace these initial conditions with this and this that we have here. Okay, so let's do that. So to do that, and I'll store that into step P2 problem 2, step 2, equal to, so I'm going to take P21 / dot, that's a replacement character in Mathematica. Since we want to replace two things now, we have to use a list. We're going to replace y of 0 greater than dash greater than with 0, comma, and y prime of 0 dash greater than with 1. So press shift enter, and that's going to give us that. It's going to replace that. So this is exactly what we would do next, replace the initial conditions after taking Laplace transform. Then we would solve for big Y. Remember now this expression is stored in P22, so let's go ahead and create a new step, P23, the third step, and we're going to solve P22 for big Y, and we'll get that. The nice thing is, what does Laplace transform do? It returns a list back here when you solve. So to navigate that list, we use double square bracket 1 comma 1 comma 2, shift enter, we get that. Now we want to take the inverse Laplace of this, which would be step P24, sorry. We want to do inverse Laplace transform. What are we going to take the inverse Laplace of this expression? But that is stored in P23, so let's use that. P23 comma, it's a function of s, we want a function of t back, and we get that back. And there's your answer. Now if you wanted to check this, we could always use dsolve again. I'll call it f again. Oh, let's call it g, something different. So dsolve, comma, curly brace. We want to solve for yt. Okay, so what is my ODE? It was y double prime of t plus 4y of t double equality cosine of 2t. Okay, with some initial condition, y of 0 was 0, comma, y prime of 0 was 1. So you press shift enter, we get that. Now you might look at this answer looks a lot different than this one, but let's see what we can do with it, if we can clean it up. First of all, greater than 1 comma 1 comma 2, to extract that function from the list, put a semicolon f of t, oops, not f, we called it g. So g of t. What did I miss? Missed a bracket. Okay, we got that. So now we can come / we can go full simplify, which is a built-in command to simplify, and then you get that. And then we can also do / expand, and we'll get that. And that's exactly what we have here. If you distribute this 1/4, we get the same solution. Okay, so you could have just done this to check your answers, or you could have done it like the way I did it, step by step, to check our work. Okay, so it's really nice that Mathematica gives you that ability to do that.